Hello and welcome to our next section in our parallel lines unit. Go ahead and grab this and put this in your table of contents, as well as the title. The title is the same as you see here, 3.4 Crook Problems. And Crook Problems doesn't sound like it's related to parallel lines at all, but it is. I guarantee you that. So it is very much related to that. And in order to do a Crook problem, hopefully you already got this title down, or pause the video, is we need a set of parallel lines to start this. A Crook problem is a very particular problem that involves parallel lines. Now, normally, we would just have we would need to show that these lines are parallel. We show that with either a set of triangles or arrows. In this particular case, I'm going to do triangles just to make it stand out a little bit more. And then we would have a transversal that goes through the parallel lines. So if, for instance, we call this line M and line N, the transversal here is the pink line, and we have a whole bunch of angle pair relationships that show congruencies or supplementary angles. Okay, so for instance, angle 1 would be supplementary to this angle. Let's call this 7, because they are same side exterior angles. It would also be congruent to, call this angle 5, because they are corresponding. And the list goes on and on. A crook problem is a problem, that, let's call this M and N again, has a change of direction in the transversal. So it's very strange for something like this to happen, but it can happen. And if you have a change of direction in the transversal, it's not really a transversal anymore. Technically, there are two different transversals that are going on here. You have the one that's going down and to the right, and you have the other one that is going up and to the left. But what happens if I have, for instance, 31 degree, let's write that in ink. Let's call this a 31 degree angle. And then for this angle here, let's call that 64 degrees. And let's put an X where that change of direction is. We want to know what angle that is in the middle. And how can we do that? Well, it has to involve parallel lines, and we don't exactly have like corresponding angles here because the transversal is changing. So what we need to do here is we need to add a parallel line. What I'm going to do is I'm going to add this change of direction. I'm going to add a parallel line right there. So you might have to use a straight edge. I'm going to just use the notability and line it up perfectly. And here, and voila, we have a parallel line going alongside the change of direction. And I'm going to call this M, and let's call this P. Okay. What we're doing in this particular part is we're going to use this angle, or we're going to use this parallel line to work with our special angle relationships. For instance, 64 degrees in collaboration with this new parallel line P. I forgot to mark this. This would be useful. Let's make sure that these are parallel. Put one triangle here. P and N are parallel, which means all the angle pair relationships follow. We have corresponding angles are congruent. Same side interior angles are supplementary, etc., etc. Now, in this particular case, 64 is an interior angle. And if you look at it, X is this full angle, but we're not interested in that full angle yet. We want to incorporate this angle here, the part of X, okay? And the part of X is also an interior angle, right? If you remember, my analogy for this is if we have a hamburger bun, we have the buns, everything on the inside is right here. And then the transversal, the red line, is your cut through the burger. So this is alternate interior angle. And as we know, if we have parallel lines, alternate interior angles are congruent. So we could actually say that this angle here, this part of X, is 64 degrees. Now, I'm going to erase these highlighted lines. I'm going to erase this one as well. Oops. And then I'm going to do another pair of parallel lines. I'm going to highlight P again. Oops. Let's do this in a thicker P and M. are also parallel. And we could talk about this transversal this time. Well, if you look closely, 31 and this part of x are also same side interior angles. I'm sorry, alternate interior angles. And we know alternate interior angles, if parallel lines, which we have, if parallel lines, alternate interior angles are congruent. So we could say that this angle here is going to be equal to 31 degrees. So we could say that this here, there you go. This angle here is going to be 31 degrees. Okay? Okay. And now, just like how we did in chapter 1, the part plus the part is equal to the whole. And in this particular case, x is the whole. So we just need to add these two together to get the angle x. So all we do here now is, what is 64 plus 31? Or actually, x is equal to, so that means x is equal to 95, or 95 degrees. The measure of that angle would be 95 degrees. Okay, so that is a Crook problem, and this is the trick. Add a parallel line to any change of direction. Of a Crook problem. Okay, because sometimes you'll have two different changes of directions, and then you have to put a parallel line for both of them. So if I sketch one out really quick, for instance, if I have this, right? And I want to know what this angle was, and I give like 30 degrees and then 110 degrees. We should technically add parallel lines here because there's a change of direction, and here. Okay, so this is the key. Add a parallel line to any change of direction of a Crook problem. Okay, if you do have any more questions about this, please let me know, and I will see you in the next one. Bye.